So very quickly, I just wrote this down. Number 5 is pretty trivial. This function is the form a f of x minus h plus k, where a is 2, h is 3, k is 5. Vertical stretch factor is 2, horizontal shift is 3, vertical shift is 5, f of x equals 1 over x. And of course your function was 2 over x minus 3 plus 5. That's this for this, and that reminds you of this form. Any vertical stretch, horizontal shift, and vertical shift will be of this form. Looks different for different functions, but that's all it is. Okay, now the next problem I want to talk just a little bit about. You're asked to vertically scale, to scale a given graph, and the graph looks like this. Yeah, reasonable facsimile. They don't always look like this, but you got a graph that kind of has a line here and then a line here. Okay? And we're going to do the equation for this function. Now this is a piecewise function, so once we have a scale, we estimate 2 points on this line to get the equation of this line, and we estimate 2 points on this line to get its equation, and then we estimate where it is this thing breaks. Okay? So we want to scale it so that the x values run from 0 to 0.4. What's that mean? It means x equals 0 here, x equals 0.4 here. And the y values run conveniently from 0 to 60. Now since the left-hand side of our, well, since this is the point 0, 0 here, we can actually say we've got the y-axis here, and we've got an x-axis here. Now if x ran from 17 to 19, you wouldn't be able to do the y-axis and the x-axis, right? Because the y-axis would be way over there at 0, and the window's only from, 17 to 19. But in this case, we can do that, and then we do the rest of the scale. It's easy to subdivide 0.4 into 4 equal intervals, 0.1, 0.2, 0.3. From 0 to 60, well, we can divide that in half, giving us 30. And then we can divide that into a couple of equal sections and that into equal sections, so we got 10. And the rest of the numbers there. Okay? So how do we get the equation of this line? Well, I'm going to cheat a little bit. I'm going to extend this line over to the y-axis and see that the y-intercept looks to be about 6. And let's see. The rise from here to here, this is 6. It looks like it goes from about 6 to 50. Okay, I'm gonna just do kind of a fundamental triangle in this thing. And I'm going to say the rise is about 10, and the run is 0.2. So slope of that line looks to be 50. Fundamental triangle anywhere in the line, but a long one, a big one, gives you more accurate results than a small one, so it's probably better to use a big one. I'm not too worried about that. And y-intercept, is about 6, so y is about 50x plus 6. Now for this one, I'll extend this out to 0.4, and the way I've drawn it, it looks like my point here is 0.460. Looks like this point, say this line goes up to here, is about 0.23 36, 37.8, okay? But I'm going to choose a point here that's got a nice coordinate. So my run between this point and this point is going to just be 0.1. And I'm going to come over here and say that looks like it's about 43. So this point is 0.343. Okay, so well, I could do a fundamental triangle here. I've got a rise of 17, I've got a run of 0.1. Thing's got a slope of 170. Now, the slope of this is 50, the slope of that one might well be 170, but don't expect my estimates to be great. I'm kind of choosing easy numbers, okay? Then I can put a point XY on here and do a fundamental triangle here, and the slope of that fundamental triangle is 0.3 minus X, that's the run, and 43 minus Y. And I've got it wrong. It's 43 minus Y. I guess I got it right. Okay, so it's 43 minus Y, that's the rise, and 0.3 minus X is the run. So 43 minus Y over 0.3 minus X equals 170. Multiply both sides by 0.3 minus X, we get 43 minus Y equals 170 times 0.3 minus X. And we multiply this out, 0.3 times 170 is 51, minus 170X equals 43 minus Y. So negative Y equals negative 170X plus 8, subtracting the 43 from both sides, so that Y equals 170X minus 8. Okay, so that was easy. I mean, it really is easy. And it doesn't say use the slope equals slope thing, but another problem might, so I thought I'd better demonstrate it. Okay? On this problem, I don't care what you do. You could even, but be careful, extend this with a simple dotted line down here and see that the y-intercept here is also about 6, although this equation says it's negative 8, but that depends on my estimates, right? Okay? So you'd get something a little different, but that would be okay. And then do the same thing you did here. Find the slope. Just pick 2 points, find the slope, extend to the y-axis. Now if you can't extend to the y-axis, you're going to have to do something else. Because sometimes, like I say, this thing will be way out away from the y-axis, right? So you got to have all the techniques for determining the equation of a straight line. And you need that, and you need that probably elsewhere in the test as well. Okay?